Hello students, welcome back to my channel. Today we are dealing with carbon and its compounds part 7, that is homologous series. First let's see the definition of homologous series. Homologous series is a group or class of organic compounds having same general formula and similar chemical properties in which the successive members differ by a CH2 group. Let's see some examples. From that we can understand what you mean by homologous series. Let's take alkenes. The general formula of alkenes is CnH2n plus 2. Let's take the members of alkenes. First one is methane. Methane, the formula is CH4, which we get it from the general formula. Now the next member is ethane. That is 2 carbon atoms are there. So it becomes C2H6. Next one is propane. 3 carbon atoms. So the formula is C3H8. Next one is butane, that is 4 carbon atoms, so C4H10. These all we will get from the general formula. Homologous series is a group or class of organic compounds. Here the class of organic compounds are alkanes having same general formula. The formula is CnH2n plus 2. And they have similar chemical properties in which the successive members differ by a CH2 group. Let's see how. If you subtract CH4 from C2H6, you will get the difference of CH2, right? Similarly, if you see the successive members, that is one coming after other, they differ by a CH2 group. C2H6 and C3H8, they differ by a CH2. C3H8 and C4H10, they differ by a CH2 group. We can say that alkanes are a group of homologous series. Let's see another example of alkenes. The general formula is CnH2n. So what are the members? Ethene, the formula is C2H4. We can substitute in that formula. Next one is propene, that is C3H6. Next is butene, that is C4H8. This is also a homologous series having same general formula, that is CnH2n, and see there are similar chemical properties are there and which the successive members differ by a CH2 group. If you see C2H4 and C3H6, they differ by a CH2 group. C3H6 and C4H8, they differ by a CH2 group. Next, if you take the class of compounds, that is alcohols, the general formula is ROH. The first member is methanol, that is CH3OH. Second is ethanol, that is CH3CH2OH. Third is propanol, that is CH3CH2CH2OH. They are homologous series because they have similar chemical properties and they have a general formula, that is ROH, and they differ by a CH2 group, that is CH3OH and CH3CH2OH, they differ by CH2 group. Now CH3CH2OH and CH3CH2CH2OH also differ by a CH2 group. What are homologous series? It is a group or class of organic compounds having same general formula. We have seen just now alkanes have same general formula, alkenes, alcohols, and they have similar chemical properties in which the successive members, that is most important there, the successive members, they differ by a CH2 group. Alkanes have general formula, they differ by a CH2 group. Similarly, alkenes, they also have a general formula, they also differ by a CH2 group. Similarly, the alcohols, they also differ by a CH2 group. They have similar chemical properties. Let's summarize what are homologous series. They are the members of homologous series differ by a CH2 group. They have similar chemical properties, but they have different physical properties such as boiling point, etc. These are three things you have to remember in homologous series. Now let's see one activity that is given in your NCERT textbook, that is activity 4.2. Calculate the difference in the formula and molecular masses for A, B, C, that is given there. That's the alcohols given there. So is there any similarities in these three? That is one question. Second, arrange these alcohols in the order of increasing carbon atoms to get a family. And can we call this family a homologous series? And the last question is, generate the homologous series for compounds containing 4 carbon atoms for the other functional groups given in the table 4.2. Now let's see how to solve this question. First is, calculate the difference in the formula and molecular masses for the first one, CH3OH and C2H5OH. So first one is CH3OH, C2H5OH. The thing you have to calculate is, calculate the difference in the formula. So what is the difference in the formula? They differ by a CH2 group. Just now we studied that. They differ by a CH2 group. So the difference is CH2. Now the second part is what? You have to calculate the difference in the molecular masses. So the molecular masses you have to calculate in these two compounds. The first one is CH3OH. The next one you have to calculate is C2H5OH. You have to find out the molecular mass and you have to find out the difference. How to find out the molecular mass? Carbon atomic mass is 12 plus 3 into 1 for hydrogen plus 16 plus 1. That equals, if you calculate, you will get it as 32 atomic mass unit. Next group is C2H5OH. So you have to calculate 2 into 2 plus 5 into 1 plus oxygen atomic mass is 16 plus 1. So here you will get the answer as 46 atomic mass unit. The question is, you have to find the difference in the molecular masses. So the difference equals 46 minus 32, you will get it as 14 atomic mass unit. So the first one is over. Similarly, you have to do the second one, C2H5OH and C3H7OH. So the difference in formula you have to find out first. So they differ by a CH2 group, right? So they differ by a CH2 group. Next thing, you have to find out the difference in their molecular masses. So first one is C2H5OH. So that will be 2 into 12. That is plus 5 into 1 plus 16 plus 1. So you will get the answer as 46 atomic mass unit. Second one is C3H7OH. So there we will get it as 3 into 12 plus 7 into 1 plus 16 plus 1. You will get it as 60 atomic mass unit. Now you have to find out the difference in these molecules, difference in their molecular masses. So 60 minus 46, you will get it as 14 atomic mass unit. Similarly, I find out the C, that is C3H7OH and C4H9OH. What the difference in the formula is? They differ by a CH2 group. Let's find out the difference in the molecular masses. One will be 3 into 12 plus 7 into 1 plus 16 plus 1. You'll get it as 60 atomic mass unit. Next is C4H9OH. So 12 into 4 plus 9 into 1 plus 16 plus 1. So it becomes 74 atomic mass unit. Now find out the difference between these molecular masses. You will get it as 74 minus 60. It is 14 atomic mass unit. We have calculated the difference in the formula and the molecular masses. Now the question is there any similarities in these three? Let's see if there are any similarities in these. See the first one, the difference in the formula is CH2. The atomic mass unit is 14, the difference. See the second one, there also the difference in the formula is CH2, their mass is 14. Here the C is what? They differ by CH2 and the difference in their molecular mass is 14. So we can say all these three groups show a similarity. That is, two consecutive members differ by a CH2 group and the mass is also what? 14U. So there are similarities. Similarities there, CH2 unit, they differ by a CH2 unit and also the mass is 14U. The second question is arrange these alcohols which we have done now in the order of increasing carbon atoms to get a family. We have to arrange them in the increasing order of the carbon atoms. So can we call this family a homologous series? That is a question. So let's arrange them in the increasing order of alcohols. First one will be CH3OH less than C2H5OH less than C3H7OH less than C4H9OH. So they are arranged in the increasing order of alcohols. Same question, one more question is there. That is, can we call this family a homologous series? That is a question. Can we call this family a homologous series? Can we call this family a homologous series? Yes. Why? They differ by a CH2 group. So here also they differ by a CH2 group. Here also they differ by a CH2 group. So we can say they follow a homologous series. Now the next question is generate the homologous series for compounds containing up to 4 carbon atoms for the other functional groups given in table 4.3. In table 4.3 certain functional groups are given. From that you have to generate homologous series for compounds containing up to 4 carbon atoms. Let's see that table that is given in your textbook. This is the table given in your textbook, that is heteroatom, functional group and formula of functional group. So let's generate a homologous series for each group. So first one is chloroalkane, second alcohol, third aldehyde, ketone and carboxylic acid. So first one, chloroalkane. So which is the first member? That is CH3Cl. If you are taking chloro, that is CH3Cl. So next one will be C2H5Cl. Next one will be C3H7Cl. Next one will be C4H9Cl. So they differ by a CH2 group each one. So we have derived a homologous series out of that. So the next one is alcohol. So first member will be CH3OH, that is methanol. Next will be C2H5OH. Next is C3H7OH. Next will be C4H9OH. See, they also follow a homologous series, they differing by a CH2 unit. Now the next functional group is aldehyde. So first one will be HCHO. Next one will be CH3CHO. Next will be C2H5CHO. Next will be C3H7CHO. So they also differ by a CH2 unit. Now the next group is ketone. So first member will be CH3 C double bond O CH3. Next will be C2H5 C double bond O CH3. Next will be C3H7 C double bond O CH3. The next will be C4H9 C double bond O CH3. So they also differ by a CH2 unit. Next is carboxylic acid HCOH is the first member. Next will be CH3COH. Then next will be C2H5COH. Next will be C3H7COH. So they also differ by a CH2 unit. Another homologous series we have to write. I hope the concept of homologous series is clear. So thanks for watching. We'll meet you in the next video.